Good morning, this is Mr. Keaton here, recording video 11.7, Geometric Probability. Little review back to some old stuff, back 5th, 6th, 7th grade stuff. Probability of an event is defined as the number of favorable events over the number of possible. For example, what's the probability of getting a 1 if we roll a die? Well, there's one way to get a 1, and there's 6 ways to roll the die, so we get a probability of getting a 1 is 1/6 on a die. Well, we can apply that same thing to geometric areas and lengths. And for example, in this problem here, the probability that a point chosen at random on AE, chosen on AE, is on CD. So that we want to know if the probability is that it'll land on C, that segment CD. So that'll be the length of CD over the length of AE, which is the possible outcomes. So length of CD looks like it's 3, goes from 0 to 3. And the length of AE goes from -3 to 5, giving us a total length of 8. So the probability of landing on CD would be 3/8. Next problem, a little trickier. It's about a train leaving a station every 30 minutes. So when the train comes, 30 minutes later, the next train will come. So it might not be leaving on the hour or on the minute. It's kind of the tricky part. Your trip to the office takes 18 minutes. One morning you arrive at the train station at 8:15. So I'm arriving at the station at 8:15. Here I am, 8:15. I just arrived. You need to be at work at 8:45. Need to be here. This is on time. So, what is the probability that you will be there by 8:45? Well, your trip to the office takes 18 minutes. So if the train comes in the next 18 minutes, and the train takes 30 minutes to get to the office, doesn't it? That means I could end up way over here. And all this time here would be late. And this time would be on time. And that's assuming the train came right when I got to the train station, because that would get me there at 8:45. So this distance here is 30 minus this 18 minutes, which would give me 12 minutes. 12 minutes. In that 12 minutes, I would be on time. And what's the total possible outcomes? Well, if it came straight at the beginning, I would be here, and I would be right on time if right when I arrived at the train station. The total possible outcome is 30 minutes. So which gives me, I think that reduced 6 goes into that 2/5 is the probability that I will be on time to work. Let's look at the next problem here. Oh, this is a dartboard. We're going to throw equally likely to land anywhere within the circle. That means we can't land out here. That's the assumption we're making. So the probability of it hitting the center will be favorable, would be in that inner circle. So area of the small circle over the total probability, which is total possibilities, which is to hit anywhere inside the big circle. So we have pi times 5 squared. That's the area of the radius of the small circle, over pi times the radius of the big circle, which is the possibility here, which gives me 25. Oh, the pi's cancel, don't they? That's nice. 25 over 144, and I think that reduces to 17%, 0.17. Let's look at the next problem. This next problem, a community sets aside a sanctuary area for birds. That's this. This is the sanctuary, kind of a weird shape. But birds equally like to be anywhere in the sanctuary. Estimate the probability that it will be in the woods. So the probability that's in the woods will be the area of the woods over the area of the sanctuary, because that's what's possible. Area of the woods, gonna have to break that into some shapes I can, or we could have used the trapezoid, but I got 16 squares here, and this is half as many, so 8. So area of the woods is going to be 24 squares. Area of this other shape, well, this is not a polygon, so I'm going to just add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 complete squares. These two I would call 12, and this one I'd call 13 together, and then I'd probably combine these into like 14.5. So I get an area of 14.5. It's an estimate, it said. I think it said estimate.